Hello viewers, welcome to my channel. I am Hasham. Last video I have explained the theory regarding the concept of time value of money. This is in unit number 2 for financial management for BBA students. So I have explained you the concept of time value of money because this concept is very important for taking a number of financial decisions like capital budgeting decision. Because all the money generated will not be at one point of time. The cash inflows and outflows we observe at different point of time, and the value of money will change from time to time due to different factors. The value of money today is much more worth than the value in future. For example, I have to pay you 10,000 rupees. I am giving two options. Do you want it right now or can I pay it after 5 years? Definitely you will say, I want the money immediately. Because today's 10,000 rupees is much more value than the same 10,000 rupees after 5 years. Future value will be less when compared to the current value. So this is a fact. And this fact should be considered while taking the financial decisions. So that's why the student must understand the concept of time value of money. So, if you have not watched the theory, I suggest you go to the playlist of my channel, select the subject Financial Management for BBA. Remember, Financial Management, different playlist you will find. Some, Financial Management is there for MBAs and some Financial Management for BCom, and this is the Financial Management for BBA students. So, select the subject Financial Management for BBA, watch the video for concept of time value of money, be perfect regarding how to calculate the compound value and how to find out the present value. That means two different values are there. Future value is the compound value and discounted value is the present value. All these things I have already explained in the theory video. Now in this video I am going to start the problems. In examination you may get the theory as well as problem. So you should be perfect. You should be clear regarding the concept and also how to solve the problem on time value of money. So before starting the problems, I expect my viewers to have a printout of the problems which I have given in the link under my description. So always keep ready. Without having the problem, you cannot understand my lecture. So take the screenshot of the points which I have written on the board, then I'll explain. Now see, in all these problems, half of the problems are based on compounding value and remaining half problems on discounting values. So first we'll start the problems on compounding value. The compounding value means future value. Presently we are having a certain sum of money. What would be the value of that certain sum of money after a period of 5 years? Taking into consideration the interest rate. Now first problem. Mr. A deposits 10,000 rupees in a fixed deposit with a bank at the rate of 5% interest compounded annually for 3 years term. How much total amount he will get at the end of 3 years? Right now Mr. X is depositing 10,000 and the banker is giving the rate of interest at 5% per annum compounded annually. Every year interest will be compounded, and how much he will get at the end of 3 years. So simple formula is there to find out the compound value after 3 years. This is the first problem. See carefully. And my suggestion, whenever you watch my video, always keep ready a notebook, pencil, pen, calculator, so that whatever I tell, immediately make the running notes. Then only you can be able to get a complete command. Now see here, the value of 10,000 rupees after 3 years can be calculated by this formula. The formula is Vn is equal to Vo into 1 plus I to the power of n. So what does it mean? N stands for number of years. So after how many years you want the compound value? 3 years. So n is equal to 3 years. I stands for interest rate. In the problem, interest rate is given 5% per annum. So 5% means 0.05. 5 divided by 100, you will get 0.05. And VO means presently how much amount you are depositing, that is 10,000 given in the problem. Now we substitute VO, so V3, we need V3, and after 3 years what is the compound value? Is equal to VO, VO is 10,000, 1 plus I is the interest rate, 5%, 0.05, to the power of N, N stands for 3 years. So we have substituted 10,000 into 1 plus 0.05, so 1.05 to the power of 3. Now if you multiply 1.05 3 times on your calculator, you will get 1.158. Immediately you check it. Use the calculator and find out 1.05 into 1.05 into 1.05. 3 times. You will get 1.158. I have rounded off to the next 3 digits after decimal. Many digits will come. I have rounded off to 3 digits. So 10,000 into 1.158, 11,580. That means if you deposit 10,000 right now, you will get 11,580 at the end of the 3 years, after getting a compound rate of interest of 5%. That's all. This is the first problem. Now, second problem. Mr. X deposit 5,000 at the rate of, there is some printing mistake there. Mr. X depositing is given. Cut it off the depositing. Deposited 5,000. Cut off that per year. Per year is not there. Misprint is there. So Mr. X deposited 5,000 at the rate of 7% coupon rate. Coupon rate means interest rate. Per annum for a period of 5 years, cumulative interest. That means interest is compounding. And what is the total amount at the end of 5 years? Exactly same, just like the previous problem, only figures are different. So here the value of 5,000. Right now we are depositing 5,000. After 5 years can be calculated. Same formula, Vn is equal to VO into 1 plus I to the power of N. Right? So in place of VO I am writing 5,000. V5 we need because we need the compound value after 5 years. So 5,000 into 1 plus. The rate of interest is given 7%. So 7 divided by 100, you will get 0.07. 0.07 to the power of N. N is 5 years. So 5,000 into 1.07 to the power of 5. So if you multiply 5 times 1.07, you will get 1.403. Check it. Make your calculation right now. You will find 1.403. Multiply 5,000 into 1.403, you will get 7,015. So that means value of 5,000 right now. After 5 years, you will get 7,050. The rate of interest is 7%. That's it. The only thing you have to remember the formula for compounding. Right? Future value we are calculating. Now, third problem. Mr. Rohan invested 35,000 in mutual fund compounded annually at the rate of 11% per annum. Find the amount receivable at the end of 9 years. Use compounding factor table. This is the new point in this problem. See here, when we have to calculate this 1 plus I to the power of N, if N is small, easily you can calculate. Example, if the N value is 3 years or 4 years or 5 years or 6 years, we can manage it. We can calculate. Suppose if N is large, suppose the number of years are 20 years. So 20 times you have to calculate on your calculator. It is time consuming and risky. Your calculations may go wrong. Risk is there. So to avoid that, we can use compounding factor table. So compounding factor table is this one. In every textbook you will find this compounding value and present value tables. You can take a printout. Else I have given this PDF of this printout in my description along with problems. So in the description of this video you will find the problems worksheet and also this table values, compounded value. Take a printout and keep it ready. In examination, in the problem itself, the compounded value will be given, or you have to carry this compound value table in your examination. It will be allowed because we cannot remember all these values, right? Now here specifically it is asking you to use the compounding factor table to find the compound value. So here, see here, amount deposited 35,000 in mutual fund, present amount deposited, interest rate is given in the problem 11% per annum, so 0.11. Number of years are 9, so n is large. So we can calculate on calculator, but it's a time consuming, it's a risky activity. So that's why we refer the compounding table. So V9, that means we have to find out the compounded value at the end of the 9th year. So Vn is equal to Vo into 1 plus I to the power of n, same formula I am applying. So 35,000 into 1 plus 0.11 to the power of 9. So 1.11 to the power of 9, 9 times you have to multiply. If you calculate accurately, it's okay. But it is better to consult the table, compounding table. Or 35,000 into CF, compounding factor table. Compounding factor, 11% is the rate and 9 years. So we want compounding factor for 11%, 9 years. Now if you refer the table, the first table, factors of compound value, on the first row we are given percentages, and in the columns we are given percentages, in the rows we are given the years, right? We want 11%, 9 years. The first page 1 to 10% is given. Next page 11% you can find. On the next page you can find the 11%. 11% to 20% is on the second page. How many years we require? 9 years. So row you can see 9. 9 years, 11%, you will get 2.558. You will get 2.558. Same thing I have written, 2.558. Confirm it by having this compound factor table. Then V9 is equal to 35,000 into 2.558, 89,530. The compound value of 35,000 after 9 years at 11% interest compounded equals to 89,530. That's it. So what is the difference between first two problems and third problem? First two problems we have not used the compound value table. Even if you use compound value table, we'll get the same answer. Because the value of n is small. Here only 3 years, here 5 years we have calculated. But here n is 9 years. That's why we have used the compound table, compounding factor table. Now, fourth problem. If you deposit 28,000 in a bank, compounded annually 12% per annum, find the amount receivable at the end of 12 years. Use compounding factor table. Even if this sentence use compounding factor table not given, we will use compounding factor. Because 12 years are there. 12 times we have to multiply. It's difficult. So that's why we'll use compounding factor table. So what is given in the problem? 28,000 is the initial deposit. Interest rate is 12%, 0.12, and n is 12 years, right? Vn is equal to Vo into 1 plus I to the power of n. So 28,000, Vo is 28,000. 1 plus I is 12%, 0.12 to the power of 12. Or, now we can use compounding factor. Instead of this formula, now we use alternative formula. 28,000 into compounding factor 12%, 12 years. Now refer the table. 12% is on second page. First page we will have only up to 10%. So here you can see 12% in the column and 12 years in the row. So 12%, 12 years is 3.896. I am seeing here 3.896. Multiply 28,000 into 3.896, 1,09,088. That means if you deposit 28,000 at 12% rate of interest for 12 years compounded annually, at the end of 12th year you will get 1,09,088. That's all. This is the end of the fourth problem. Now, fifth problem. If you deposit 10,000 today at 8% rate of interest, In how many years will this amount double according to rule 72 and according to rule 69? This is a different problem. Doubling period problem. Actually, how many years we require to double the amount at a given rate of interest? For this, we have to refer the compounding value table, and arbitrarily we have to check. We have to try a number of rates, a number of periods. Then only we can get how many years we require to double our amount. So, but shortcut method have been given by authors, and those are the two rules. Rule 72 and rule 69. One formula is there, simple formula is there. By using that formula, we can be able to get how much time period is required to double the amount, right? But this is only a rough method, a raw method of finding out the doubling period, not the accurate. It's not 100% accurate, but it's very near to actual. Doubling period. Rule 72 says doubling period is equal to 72 divided by rate of interest. Very simple formula. 72 divided by rate of interest, you will get the doubling period. So here in our problem, rate of interest is 8%. So 72 divided by 8, 9 years. So whatever amount, that means here 10,000 is deposited. If you deposit 10,000 right now, it will become 20,000 in 9 years. At what rate of interest? 8%. This is rule 72. One more rule is the rule 69. According to rule 69, doubling period is equal to 0.35. This is there in the formula itself. 0.35 plus 69 divided by rate of interest. So 0.35 plus 69 divided by rate of interest is 8. So 69 by 8 you will get 8.625. So if you add up 8.975 years. According to rule 72, it is 9 years. According to rule 69, 8.975 years, almost very near. This is the formula for doubling period. Next, sixth problem. If you deposit 20,000 today, 8% rate of interest, in how many years will this amount will grow to 1,20,000? Work out using rule 72. Rule 72 we have to apply in order to find out how many years we require to convert 20,000 to 1,20,000. So presently we are depositing 20,000. In how many years we require to convert the 20,000 to 1,20,000? By using rule of 72. Deposit amount 20,000, rate of interest 8%. It has to grow to 1,20,000. First of all, rule 72 says doubling period is equal to 72 by rate of interest. So 72 by 8% is the rate of interest. It will come now 9 years. That means from 20,000 to 40,000. To make 20,000 to 40,000, it requires 9 years. So for becoming first 40,000, it requires 9 years. Next 40,000, again 9 years. Again next 40,000, you will get 9 years. So 40 plus 40 plus 40, 1,20,000. To make 1,20,000, to get 1,20,000, we require 9 plus 9 plus 9, 27 years. So 20,000 will become 1,20,000 in 27 years, according to rule 72. That's it. Now, seventh problem. Mr. P wants to double his investment 70,000 in 8 years. What is the required rate of interest? Use 72. Here doubling period is given. The doubling period is 8 years and we require interest rate. So seventh problem. So what is the formula according to rule 72? Doubling period is equal to 72 divided by rate of interest. Here doubling period is given. How many years the amount is doubled? 8 years. So in place of doubling period, I am writing 8 years. 72 divided by rate of interest. Now if I make a cross multiplication like this, what will happen? 8 into rate is equal to 72 into 1, 72. So 8th rate of interest is equal to 72. 8 into rate of interest is equal to 72. So rate is equal to 72 by 8. That is equal to 9. So what is this 9? Rate of interest. The rate of interest is 9%. Simply we have interpolated the formula. No new formula is there. Doubling period is given and rate of interest we have calculated. Now, 8th problem. Mr. Smart has 5,000 rupees that he has saved from doing odd jobs around the neighborhood. Story is given. He is having 5,000 right now. When he graduates from college in 4 years, he would like to have 10,000 to use as a down payment on a new bike. That means presently he is having 5,000 and it will become 10,000. That means double. In how many years is doubling? 4 years. So doubling period is 4 years. And at what interest rate will have to invest his money? Same. We have to find out what is the rate of interest when the doubling period is 4 years. So according to rule 72, doubling period is equal to 4 years. Rate of interest how much? So rule 72 says doubling period is equal to 72 divided by rate of interest. So how many years? 4 years. So in place of doubling period I am writing 4. 72 by rate, cross multiply. So 4 into rate, 4 rate is equal to 72. So rate is equal to 72 by 4, that is 18%. That is the rate of interest. That is 8th problem. 9th one. Calculate the compound value of 20,000 at the end of 5 years at 12% interest rate when interest is calculated on yearly basis. Exactly same. It is compounded annually. 5 years, 12% and 20,000. Now see. VO is equal to 20,000, N is equal to 5 years, I is equal to 12%. Interest is going on, interest is on yearly basis. So Vn is equal to VO into 1 plus I to the power of N. So VO is 20,000, 1 plus interest is 12% and period is 5 years. Right? Or V5 is equal to 20,000 into compound factor, 12% for 5 years. Again, we go to the table. 12%. So here, second page, 12% 5 years. You will get 1.762. 1.762. Here. So 20,000 into 1.762, 35,240. The compound value of 20,000 rupees after 5 years at 12% rate of interest, it will become 35,040. That's it. This is the 9th problem. Now I am moving on to 10th problem. The amount of 1 lakh rupees is invested at 14% per annum compounded half yearly. New problem. प्रीवियस जितने भी प्रॉब्लम्स करे थे वहां पर कंपाउंडेड एनुअली था, लेकिन अब जो करने जा रहे हैं ये कंपाउंडेड सेमी एनुअली. सेमी एनुअली का मतलब इंटरेस्ट इज कैलकुलेटेड एवरी 6 months. फाइंड द अमाउंट रिसीवेबल एट द एंड ऑफ 3 years. 3 साल के बाद कितना अमाउंट होगा 1 लाख रुपीस का. राइट? द फॉर्मूला विल बी स्लाइटली मॉडिफाइड. चेंज करेंगे फॉर्मूले को. Compounded semi-annually, that is a new point. If interest is compounded semi-annually, the compound value is calculated as follows. Vn is equal to Vo into 1 plus I divided by m to the power of m into n. M is not there when annual interest, when compounded annually. When compounded semi-annually, divided by n, I divided by m to the power of m into n. So Vn stands for compounded value, Vo present value, I stands for annual rate of interest, m stands for number of compounding periods per year. How many times we are compounding in 1 year? If it is semi-annual, then 2 times. If it is quarterly in 1 year, 4 times. If it is monthly, it will be 12 times in a year. So m will be 2 if semi-annual, m will be 4 if quarterly compounded, m will be 12 if monthly compounded. So we have to see whether it is semi-annual, quarterly or monthly. Number of compounding periods per year. N is equal to number of years. Now in our problem, VO present amount is 1 lakh. I is equal to rate of interest 14%. 14% means 0.14. M is equal to 2. Why I am taking M is equal to 2? It is not given in the problem. It is saying semi-annual. When semi-annual, it means twice in 1 year, every 6 months. So in 1 year, 2 times. And N is equal to 3 years. That is given in the problem. Now we substitute. V3 is equal to 1 lakh into 1 plus 14 divided by 2 is 7%. 0.14 divided by 2 is equal to 0.07. 2 into 3 is 6. So 1 lakh into 1.07 to the power of 6. Or if we use the compounding factor, then 1 lakh into compounding factor 7% for 6 years. In bracket, the power is 6. That means 6 years. And here 0.07, 7%. Now if you refer the compounded table, compound factor table, 7% for 6 years. First page. 7% for 6 years. You can see here 1.501. 1.501 here. So 1 lakh into 1.501, 1,50,100. This is the compounded value after how many years? 3 years. When interest is compounded semi-annually. So this is the new point, new formula. Now one more problem I am going to explain in this video, that is 11th problem. How much will be in an account at the end of 5 years if the amount deposited today is 10,000 at 8% interest per year, compounded semi-annually, just like the previous problem. That means I divided by M whole to the power of M into N. That is the new point. So here V5, we want compound value at the end of 5th year. V5 is equal to VO into 1 plus I by M into the power of M into N. So 10,000 we are depositing. Rate of interest is 8% given in the problem. So 0.08 divided by 2, you will get 0.04. And 2 into 5, 5 years are there. And every year 2 times. So 2 into 5, 10. So 1.04 to the power of 10. But we will not calculate power 10. It will be time consuming. We again refer the table. So compound factor 4% for 10 years. If you go to the table and find out 4% for 10 years, you will get 1.480. So 10,000 into 1.480, 14,800 is the compounded value after 5 years. After 5 years. So therefore, compound value of 10,000 after 5 years, if interest at the rate of 8% per annum, compounded semi-annually is 14,800. 11 problems I have explained in this video to the best of my ability. Hope you understood. If you are still having some doubt, watch the video 2-3 times. Watch the theory video. Then only you can get a lot of comment. You can enjoy learning the subject of financial management. So if you are satisfied, give a like to the video. Share my channel among your friends, among your group, so that more students can watch the video. And subscribe my channel if you have not yet subscribed. Inshallah, we'll continue the next problem in the next video.